Due to the high travel speed of a robot, consider using the short circuit mode of transfer on robot applications that are less than 60 thou or 70 thousandths of an inch, 1.6, 1.7 millimeters. Robots can use spray transfer on applications thicker than 70 thou. The pulse transfer mode can be used on parts as thin as 60 thou, 1.6 millimeters. Typical short-circuit wire feed range utilized with the robot is 200 to 300 inches a minute. A voltage range of 16 to 18 volts is normal. Weld travel rates of 20 to 40 inches per minute are typical. The faster the weld travel speed, the lower the weld voltage required. If you see spatter, lower the welding voltage. Always listen to the short circuit arc sound. A smooth, consistent crackle sound is a must. A plopping or a soft sound means you must lower the voltage. A harsh crackle sound, inconsistent sound, means you must increase the voltage. For short circuit start weld data, use 2 volts higher than the pre-programmed weld voltage. For short circuit end data, use 2 volts lower than the pre-programmed weld voltage. If burnbacks occur, lower the start voltage. Also decrease the wire stick out. If inconsistent arc starts occur, check that a large weld droplet has not formed on the tip of the wire at the weld completion. If this droplet is evident, lower the end data weld voltage or crater fill weld voltage. Optimum start data for short circuit welds. Try 250 inches a minute wire feed speed with 18 volts. To minimize burn through at arc starts and also to keep the weld from becoming too large, ensure that the pre-ignition time is minimum. You do not need pre- or post-flow gas times. The prime concern with most sheet metal welds would be to avoid weld burn through. In contrast, the prime concern with all spray transfer welds should be to attain sufficient weld fusion. All robot welds should be pre-qualified from a weld fusion perspective. And remember, when setting the robot weld travel rates, that this has the greatest influence on the weld fusion attained. When welding on parts less than 3 millimeters, the first thing you should do is produce a weld in which you eventually burn through the part. By doing this, you now know what the high end of the weld data is that you should not use. Then weld the same part with lower parameters till the weld fusion is borderline. You now know the low parameters that should not be used. And that's the key to setting weld parameters with robotic applications, to know what shouldn't be used. A common problem with robot welds is the diversity of the welding data utilized. For example, a welded part may be 3 millimeters thick, and it requires 10 welds. Many programmers would program each weld with very different weld data. The 045 wire may have a wire feed rate of 400 inches a minute for one weld, and then another weld at 350, 380, 420, 480, etc. This type of programming is unnecessary and creates problems when welding issues arise. The bottom line, the optimum spray parameter range is narrow, 400 to 500 inches a minute. Use a single setting, 420, 450. If changes are required on this application, first adjust the weld travel rate and then adjust the voltage. That $1 contact tip in the robot cell will frequently cause a loss of robot production. It's not uncommon to find 30 minutes to 60 minutes of robot downtime due to contact tip problems. The two prime problems with a contact tip are wire burnback and well spatter. Burnbacks with spray transfer are frequently caused by setting well start data which is too high. For spray arc starts, use low spray parameters. With an 045 wire, for example, use 380 to 400 inches a minute with 26 to 28 volts. To minimize well spatter buildup on the contact tip, you can do the following. 1. Ensure that the tip is recessed at least 4 to 6 millimeters. 2. Increase the tip cleaning cycle frequency. 3. Ensure anti-spatter liquids are used in the cleaning cycle. 4. Make sure the welding voltage is set to minimize well spatter. Ensure also the weld start and end data is not set with globular parameters. 6. The pulse process provides less spatter. Weld spatter can be minimized. Keep your attention on the welding voltage. Use the arc sounds. Remember, you want to produce a smooth, consistent crackle sound. That's an indication of a correct voltage setting. The combination of a low-energy gas mix and high weld travel rates will result in low welding voltages. Ensure in this circumstance that for the weld start, the voltage is sufficient. It's not unusual for a weld start data to have 2 to 5 volts greater than the actual welding voltage. For the voltage at the weld ends, or the crater fill voltage, take the weld voltage and reduce it by 2 to 3 volts. In ignition data, with spray transfer, an ignition delay time is important. A pre-flow time of 0.3 to 0.5 seconds is normal. This allows the gas to get down to the nozzle before the start of the weld. Post-flow is also essential. The larger the weld, the longer the time. What about robot welding speeds? When welding on parts less than 3/16, less than 5 millimeters, weld travel rates of 40 to 60 inches a minute are typical. The common 1/4-inch fillet weld requires 15 to 25 inches a minute. The larger 5/16 fillet weld is normally done at a weld travel rate of 8 to 12 inches a minute. With robots, a slight weave or oscillation of the weld improves the weld fusion, and this is particularly important once the weld is greater than 6 millimeters or 1/4 inch. On heat-sensitive parts, find out which are the sensitive welds and weld them first while the part is still cold. What we've discussed in this training film is really understanding parameters. We don't have to remember the type of amperage for every thickness. We simply have to remember that if we're welding thin metals, that to simply put the wire feed around the 11 o'clock position, or if you have a digital wire feeder, set it up around 150 to 200 inches a minute. And remember to put the voltage for short arc at, well, 17, 18 volts. And if you're welding the very thin metals, then put the voltage at 16 volts. As we go into the thicker materials, we go into spray transfer. And with spray transfer, we simply put the voltage. Now we add another 10 volts to what we had when we were short-circuiting welding. So 27 volts. Put the wire feeder around about the 2 o'clock position. Or again, if you have a digital wire feeder, put it about 400 inches a minute. Then make slight adjustments on the arc. If you see spatter, it usually means the wire is driving into the weld. If you slightly increase your voltage, a gap will be created between the end of the wire and the weld, and we will have less spatter. So you can either slightly increase voltage or slightly reduce the amount of wire that's running into the weld. That's what spatter is. It's the wire running into the weld. We'd like to thank Fruhoff Trailer Company here in Canada for their cooperation in making this training film. And we hope it will be of some benefit to you. Thank you.